So today we're going to start with acid nomenclature. The naming of acids. It's going to be similar to what we did last week with various compounds, except this is going to be about acids. When we talk about acids, there are actually several definitions and several ways to define acids. For our purposes, we are going to start with acids being something that donates a hydrogen, and so it's going to begin with H. All right? And so when you see something that starts with H, you're going to say to yourself, that's an acid. All right?
An example would include?
Well, we will get to some examples as we go through, but for example, look right here at HCl.
So hydrogen is technically an acid?
No, not when it's by itself, only when it's bonded to other things. So let's look at, again, when we talk about binary, that means two. And so when we talk about a binary acid, that's going to be something composed of two elements, which is going to be hydrogen and something else. So not just hydrogen itself. So it'll have to be hydrogen and another element. Something like HCl or HBr. Okay? Any of those things would be an example of a binary acid, where you have the H and then some other element. So H and then some other element. Now, the way that we'll name this, when we only have two, when we only have two elements, the H and the other element, is we will call it hydro.
Is that
And
H plus right next to it?
it H plus another element.
Okay, thank goodness I couldn't see it.
That's okay. And so we will name it hydro, and then we will insert the stem from the element. Like, since this is chlorine, we would say chloro, and bromine would be bromo. Okay, or like chlorine, and then we'll take off the INE, or bromine, and take off the INE, and add IC, and the word acid. So HCl will be hydrochloric acid, or hydrobromic acid, or hydrofluoric acid. Or H2S would be hydrosulfuric acid. All right? And so I'm just going to highlight a couple of things here. Hydro, and then ic. All right? And then, of course, whatever the root from the other element is. Okay? And so that is how we will do that. Now, in terms of balancing that, we still have to look and say, hey, hydrogen is going to be a +1. Chlorine, since it's in the group 7A, is going to be a -1 ion. So a 1 and a 1, it's a perfect match, and we'll end up with HCl. Hydrofluoric will be the same way. Hydrosulfuric. Hydrogen is a +1. Sulfur is in the group 6A. And so when it ionizes, it will ionize to have a -2 charge. And then that negative 2 will come down here. That +1 will zip across there, and we'll end up with H2S. Okay, hydrosulfuric acid. All right. Questions about how we name a binary acid? All right. Naming the acids is not necessarily difficult. It's just a matter of memorization and memorizing the rules that go with it. You will find that the rules themselves are pretty straightforward. It's just a matter of keeping them straight in your mind in terms of which one goes with what. All right. So that is those are examples of our binary acids. Now I want to swap down and let's see, let's go with a little bit of green. And let's talk about a ternary acid. Now, a ternary acid is going to have 3 or more elements. All right? And the way that that's going to work out is it's going to involve our polyatomic ions, which are the multi-atom groups that are found on the back of our periodic table. Right now, I want you to look on the back of your periodic table, and I want to.
We can scroll back up a little bit, right?
Okay, there you go. And this will be posted. This all the typewriting is in Google Classroom. All right, and what I'm going to do is I'm going to come to about here. And before we talk about any of this, I want to talk about just our polyatomic ions for a moment. All right, I want you to look on the back of your periodic table, and I would like you to find a chlorate ion. Okay, it's going to involve chlorine, and it's going to involve some oxygen. But the question is, how much oxygen and which charge? Find that chlorate ion. Tell me again.
3 oxygen minus 1 charge.
All right, so ClO3 and minus 1 charge. And that is a chlorate. And that is a chlorate ion. Okay? Now, so I always like to start just with the basic 8. So your 8 will have a certain number of oxygens. Okay? Chlorate, it's got our chlorine and then a certain number of oxygens. Now, nitrate might have a different number of oxygens. Phosphate will have another number of oxygens. So the number of oxygens will vary in terms of which one is your 8. All right? But chlorate has ClO3 and -1. Now, from your 8, if you reduce the number of oxygens by 1, you will then have a chlorite. All right? And so from your 8, if you decrease your oxygen by 1, you will have an ite. And that's true for everything. Like over here, if I have sulfate, which is SO4 minus 2, then what would sulfite be? Well, I decrease my oxygens by 1, and it would be SO3. Okay? And so here's my basic 8. Here's my basic ite. Okay, and again, chlorate, chlorite, sulfate, sulfite. And it's not always 4, it's not always 3, but whatever your base is, whatever your starting point is, which I always start with the 8s, if you go down 1, you get an ite. Now, if you go down 1 more, ClO, in this case 1, and so we won't write it, and still with the -1 charge, that is going to be hypochlorite. Okay, so you still have the ite, but it's hypo. So chlorate is a certain number, your 8 is a certain number, down 1 is your ite, down another is your hypoite. All right? Everyone comfortable with the naming, with how this is happening for our polyatomics? Okay. Hey, and just look on the back of your, periodic chart and confirm that I'm telling you the truth. All right, let's find carbonate. Oh, there's carbonate. Oh, good, and they don't actually put carbonite or hypocarbonite. Oh, wait, not carbonite, chlorate. There we go. Chlorate, chlorite, and they don't have hypochlorite. So you will just have to take my word for it. All right. Now, we talked from our 8 about if we went down a couple, What if we bump it up a little bit? What if I take ClO4? And so we have perchlorate. Like hyper, but without the high. So it's a less friendly hyper. So we have perchlorate. All right, so one more time, just to review. Here we have chlorate. Down one oxygen gives us chlorite. Down another oxygen gives us hypochlorite. Up one oxygen gives us perchlorate. All right. So from here up to SO5 would be persulfate, and down one would be hyposulfite. Okay. So just a quick little explanation of that. Now I'll tell you why I went through all that. I want you to understand the basis of this naming. Okay? That if you have whatever your 8 is, if you go up one, it's just going to be a per. If you go down one, it's going to be an ite. Down another, it's going to be a hypoite. And the reason that matters is because your 8s and your ites will come into play here. Now, I want you to see that your ternary acids, that there are going to be 4 different naming schemes. Okay? So just kind of follow along. When it ends in 8, then we're just going to replace your polyatomic ion ending with ic. So 8 turns to ic. All right? So if you have a nitrate and you put a hydrogen with it, or the appropriate number of hydrogens. So nitrate is NO3 minus 1, and so it would get matched up with H+. And so a nitrate with hydrogens becomes nitric acid. And so the 8 turns to ic. All right? What about a sulfate? Remember that a sulfate, look and find its charge. I'll give you a hint. That's right, it's -2. Good job. Hey, do we see that on our chart that sulfate is -2? Yeah? Okay, some of us do. Good. And so, since H+ is just a +1, we will crisscross those. And if you have a -2, then you're going to have to have a pair of +1s in order for that to connect. Oh, my tablet died. Man, sad times.
Does that mean that we're done with notes?
No, we are not done with notes. Hey, here we go. Let's regain our composure. So the SO4 has a -2 charge. The hydrogen has a +1 charge. That means we're going to need a pair of hydrogens in order to provide enough electrons for the sulfate to accept. All right. So H2SO4, and sure enough, then that's going to be, since it's an 8, sulfuric acid. Chloric acid, perchloric acid, phosphate. So if it's an 8, either chlorate or perchlorate, then it will turn into an ic. All right? Everybody comfortable with that? All right, so let's slide on down here to the ite. All right, now if it ends in ite, then we will change that ite to us. This is the way that I remember this, is I say it's an itis, like some sort of disease. And so I always just, aidic, I just have to remember, but itis is the way that I remember the other part. So if it is an ite, whether it's a chlorite or a hypochlorite, it will turn into an OUS. If it is an 8 or a per 8, then it will turn into an ick. All right? So, and then again, just as we had H2SO4, which was a sulfate, if you look, you'll find that SO3 is a sulfite. Again, ClO2 is a chlorite. NO2 is a nitrite. And all of those things then will just have their ite turned to OUS. Whoops. Meant to have that. And so our ite will turn to OUS and will become a chlorous acid. We do not put the hydro in front of this, so that's different from our binary. It's binary that gets the hydro. It is the polyatomics get your adic and your itis. All right, and then what we said earlier, if it has fewer oxygen atoms than ite, then you prefix as hypo and you still get your OUS ending. Hypochlorous acid, okay, from your hypochlorite. All right. And if it has more oxygens,
Go up a little bit and finish writing some examples.
okay, there we go. All right, and if it has more than that, then it will have a per and an ick ending. Again, if I have, let's see, let's go with some Purple Panther. If I have a ClO4 with a -1 charge, and I would like to bond that with some H plus, I will get an HClO4. Now let's see, this was a perchlorate, which means that we're going to keep the per and we're going to keep the, and we're going to convert the 8 to the ick. So this will be perchloric acid. Okay. And again, we'll all right, feel good about that? All right, and I will roll down just a little. Just a little. Okay. Again, HClO4, the same example that I used there. Our perchlorate ion, which is our perchlorate ion, which I will circle here. That means that we keep our per, we keep our chlor, and our 8 turns into ick, and we add an acid for the H. Okay. Again, just chlorate turns into just chloric. Now here's something that I want you to notice. Let's see. I think we will have another example below. All right, I'm going to roll down, but I'll roll back in a minute if we need to. All right, we've sort of got some. Here's what I want us to notice. All right, if you've got HClO3, you've got chloric acid. HClO2 is chlorous acid. HClO is hypochlorous acid. HClO4 would be perchlorous acid, and then just HCl would be hydrochloric because it's binary. And so what I want you to see is that some of these, especially if it's a common acid as a binary, but also a common acid as a polyatomic, is that you're really going to have to pay attention to the wording to know which ion or which element is involved. Okay, you're really, again, none of this is brain surgery, but you're really going to have to pay attention and have studied to keep your rules straight. Okay? So it's not hard, but it will take some work just to keep the rules straight. Okay? Same thing for, we've got sulfuric, sulfurous, hyposulfurous, and then of course just H2S, which is hydrosulfuric. So the difference between sulfuric and hydrosulfuric is whether you have H2S or H2SO4. So you've just got to pay attention and be careful. Are there questions about the naming of acids?
Just can you scroll back up?
All right, I will scroll back up and look at that, and then we will work a little bit of practice.